Cool. I'm going to stay on camera just for the first couple of slides, and then I'll drop off after that because, like, oh my God, COVID-19 here. I need a haircut and bad. But thank you, everybody, for joining in. This is like the third or fourth one of these we've done. There's been a lot of interest, which has been really cool. I want to say thank you to all the folks that are involved with making this happen, not just the organizations themselves, but all the folks in the background. I mean, you've seen Shelby, there's Keith, Jason, KC's back there. We got a lot of folks helping out, answering questions, and kind of running from there. Classes I've got coming up, I'm going to be teaching how to sell security to senior management. I think we actually kind of renamed that to how to sell security to C-levels, because that's really kind of more the focus of this. This is a huge problem, meaning that when you kind of look at like how we go about trying to get funding or to try to get support for senior management, a lot of it really comes down to two things. One is we don't do our homework and we're speaking the wrong language. We're talking, French to a bunch of Italian people type of thing. And we need to get better at that. So I'm going to be doing this says tomorrow. It's actually not tomorrow. It's going to be the 20th. So it'll be next week. So I'm doing a 1-hour webcast on that. That's kind of a primer. But I'm also going to do a full 4 hours per day class on doing this. There's a lot of peripheral information. Folks might find that useful, especially now where, getting funding is a little bit harder. This may, hopefully kind of help folks out. So feel free to hit the Wild West Hack and Fest website to be able to sign up for that. I'm going to go off video because, hey, people don't need to see. There we go. So next threat hunting class, like I said, this will be in August. John's going to be running point on that. And John's going to bring this more to the endpoint side. This one I've changed a little bit from ones in the past because I want to do a little bit more of a transition, meaning that I want to look at this more holistically. I want to look at this more. In the past, we've kind of hit on how do you do that initial find that, hey, you've got something bad. I want to start transitioning this more to, okay, so once you find it, how do you start doing the forensic rundown? How do you kind of run this to ground from here?
Yeah,
also works.
I was just going to say, and there's so many things. Chris is going to be sharing a project that we've been working on with the endpoints. I'll share that with all of you in a little bit. But there's a bunch of stuff whenever it comes to Project Sigma, elk stacks, using tools like Kansa from David Hull to be doing all kinds of really cool things with the endpoint. But one of the big things about these webcasts is how you need to marry the two. You need to marry the network with the endpoint data to get a complete picture.
Yeah, exactly. And we've got a 2-day paid-for class that's coming down the pipe, figure July or August or so, that one will hit. And this class will be a prerequisite for that. I want to do something that kind of, we've had like 6,000 people go through this training. I want to have something that builds on this that is mostly hands-on. I want the class to be mostly, okay, here's a trace, go figure out what's going on, run it to ground. Is it something we need to worry about or not? If it is, what do we do next? If it's not, what do we do next? I want to be able to do 2 days of reinforcing that whole concept. So you'll see that coming out over the next couple of months. All right, so before we get started, you should have the VM for this class already. There's a new password protecting that page. Here it is here. Hopefully you got this as part of the email when you joined up. The login on the VM itself is the same because it is the same VM. There's a VirtualBox version. There's a VMware version. You don't need network access from this VM, meaning if you spin the VM up and then you go and you look at, like, hey, what IP address did I get? And there's no ETH0 interface, that's okay. You don't need network access to be able to do these labs. Although it is helpful if you can actually SSH into it or you have the proper tools loaded to be able to copy paste things. That way, when we get into the labs at the end, you'll be able to, if you're stuck on something, you can just kind of copy the command I had in the slide, paste it into your SSH session or your terminal session. That way you're not having to try and, manually type things and make mistakes and all of that fun stuff. So, as Shelby said, we're going to be doing a 10-minute break at the top of each hour. If you have questions that are kind of specific to the content that we're covering, go ahead and throw that in the webinar chat channel. And folks will help you out if it's easy. If not, they'll kind of toss it up to me, and that's fine. Everything else, let's throw that into the Discord channel. So if you have things that are like specific to your environment, or it's kind of related questions, but not really on the topic that we're talking about, hey, go and hit that. We have an awesome, awesome community that started here. One of the things that I think is really cool is on the last couple of webcasts, other folks have been presenting. I've been working Discord. And most of the time, other people respond with the right answers before I can actually respond. It's been really cool to see. We've got a really helpful community here. Folks play nice with each other. What I love seeing is there's no egos. I've been involved with security groups where it's oh, how dare you ask such a stupid question, and folks kind of get off on belittling each other, and it doesn't happen here. We're kind of recognizing that, hey, we're all kind of starting. Everybody's got to figure stuff out. Let's play nice and help each other out as best we can. And it's just really cool to see that taking place. Especially at the start of this webcast, so in the past, I've just kind of like jumped into the whole threat hunting side and kind of run with what we've been doing. But I want to change it up a little bit because I want to challenge some of the preconceived notions we have about how to do threat hunting. Meaning, like, there's lots of folks out there that if you say, hey, do you threat hunt your network? They'll say yes. And then you kind of look at what they're doing and, no, they're not. Oh, yeah, we threat hunt the network. Anytime our antivirus triggers, we take a look at that. That's not threat hunting. Keep an open mind about this. This gets hard because there's times that, like, we're doing something that doesn't really work. It seems to work a little bit, but not really. And we kind of get vested in it, and it's kind of hard to let go of it. Think of it as like kids. If you have a 5-year-old and that 5-year-old tends to misbehave and not be helpful around the house, you will come up with excuses for them. It's your baby. You do that. And we tend to kind of do that with our solutions. We don't really pull back and look at, is this solution work or not? It's referred to as cognitive bias. There's a lot of that in this industry. And I'm going to challenge some of that as we go through these. So if you think about how, what's the historical way to go about trying to catch the bad guys? It's centralized log collection. So we'll take all our systems, we'll have them send their logs down to a central location, a Splunk server or whatever it is you want to use. Could be an Elk stack, doesn't matter. Some central location. And then we're going to go through and we're going to kind of mine that data to try and find, when are the bad guys doing things. And if our signatures go through and kind of find something interesting, then we'll go through and we'll do a follow-up on that. Well, let's kind of back up a little bit and kind of first look at what are we working with. The lowest common denominator is syslog. The lowest common denominator for getting logs off of one system into another in a format that everything will understand along the way is syslog. Syslog is made up of a couple of different parts. There's the header, and the header is just generated by the local system. So imagine this is a log entry that showed up on our centralized logging server, so it's collected it off of a remote system. That header information was actually generated by the logging server itself. So it's going to identify, when did I receive this message? Not necessarily when did this event occur on that remote system, but when did I see it and where did it come from? And then we have parts 1 and 2. Parts 1 and 2 just kind of make up, what is this message about? Part 1 is always, this is our application, this is the process ID it was running under. And then part 2 is kind of freeform. It's like whatever the programmer of this application wanted to have sent as a message, that's what's going to kind of show up here. And all of this is worked around, syslog has different facility and severity levels. So a facility is, what type of log message is it? Is it email related? Is it UCP related? And one of the problems with this is syslog dates back to like 1987. So I mentioned, is it UCP related? Nobody uses UCP anymore, but that is one of the facilities we can choose to use. There is no web facility because web didn't exist. So when we try to kind of relate it to things, that's where the facility comes in. Severity is, how important is this message? It could just be informational, it could be an emergency. And the combination of facility and severity generates what's referred to as a priority number, and that's the number that I have circled here. So if I decode the packet as it goes by on the wire, what ends up getting sent is, here's the priority number for this message, and then here's part 1 and part 2. What that priority number does is it gives the receiving system some way to go through and kind of sort it beyond trying to pattern match on text that's within the rest of the message. So if I want to like handle emergencies different than informational stuff, it gives me the ability to go in and do that. If I want to handle email differently versus other things, I can go in and I can do that. So by working with that priority message, that gives me a little bit of filtering capability, but it's pretty minimal. Now, one of the first challenges we run into is none of these are security related. In other words, we tend to use syslog not so much for troubleshooting, which was its original intent, but we're trying to like bend it and use it for security. Well, there's no security severity level. There's, informational, there's emergency like I was talking about, but there's not one for security. And we kind of need that, because if the application vendors would label their messages as being, hey, this is something security related, wow, that would make our whole life a whole lot easier. But there's not even an option for that because of the spec. There is a facility that is labeled security, but really it's for local system audit logs. It's not really designed to identify security events associated with the different applications of the kernel that's running on that system. So we've got no way to label it properly as a security event. We have no standard for how to write security messages, within that part 2 section that I was talking about. So we've got no consistency there. Oh my God, this ends up being a cluster. So, so problem number 1 is we're relying on a protocol that really wasn't designed for security. It was designed for troubleshooting. And because of that, there's a lot of pieces missing that we could really try and use. But we've tried to mold it into something security related anyway. The other issue with system logging is you never really know if you got everything, and usually you don't. I've yet to see a single environment that I've gone in to do an audit for that could actually claim legitimately they're logging everything. There's always stuff missing. There's always some IoT device, there's some desktop they missed, there's a couple of servers that somebody set the wrong IP address and it's sending logs off to nowhere. And this is a fail open type of system. What I mean by that is if we had a situation where if I brought a new desktop online and unless I was collecting logs, that thing got no network access, that would be kind of cool because now I know for certain I'm collecting those logs. But the way networking works in general, I bring up my system. If I'm not collecting logs, you might not even necessarily know I'm even there, not unless we're getting in a NAC and all these other little functions. It's a fail open situation. So you can miss this stuff and not even know it. I can go to sleep at night thinking I'm logging everything, when in fact I might not even be close. We're trying to collect everything, but not necessarily getting all of it. We're using a protocol that really wasn't designed for security. We're dumping it onto a centralized system. What do we do with it when we get there? Well, we go in and we do pattern matching, right? We go in and we say, oh, if I see a failed login, that's something worth paying attention to. Well, is it really? How many of our users get a password wrong on a daily basis? How often do you do it yourself? I mean, this is kind of common. Oh yeah, I thought I remembered what password I was using. I didn't. It's not uncommon for that to fail. So we're going in and we're pattern matching for a string that we know is interesting, and we're trying to leverage that for security. Well, if you think about it, that's how antivirus worked back in the 90s, right? Look at the code running in memory, pattern match on something. If you see that, warning Will Robinson, you got a virus to worry about. And we don't do that anymore. We've shifted more to like whitelisting because pattern matching, just quite honestly, kind of sucks. It doesn't really give us a consistent accuracy. There's false positives, the false negatives, and we got the same thing here. Also, sometimes context really matters. And some systems will give you that a little bit. You might be able to go in and look at things like, show me 3 or more failed logins if they're followed by a successful login. Okay, that might show me some folks trying to brute force in, but I'm still going to get false positives out of it. So it's this balancing act where we're generating alerts on things that are kind of interesting, but maybe not. And we get ourselves in this mode of learning to ignore our alerts. And anybody who does system log review, come on, you know what I'm talking about, right? How many of the alerts do you have that go off on a daily basis that you look at and just immediately dismiss? That you look at and you say, yeah, I see that all the time. That's a false positive, and you just ignore it. So part of the problem with this system we've built is because it's not really doing what we need. It's coming close, And we can generate tests that make it look like it works. And we can say, yay, yay, we're doing awesome. Hey, look at that. I typed my wrong password a couple of times and this thing generated alert just like I expected. Great, I'm protected. Yeah, maybe not. But we're counting on a way to kind of catch this stuff that's lulling us into a mindset where we're learning to just kind of ignore these things. So this whole pattern matching just doesn't work. And oh, by the way, this whole process of collect logs to a central location, pattern match on some stuff that's there, and hope you find the bad guys, we've been doing this forever. We've been doing this longer than stateful firewalls has existed. This is probably one of our oldest security technologies to fall back on. So, when you look at what was going on in the world when this was the way to go about securing things, yeah, this is what people were wearing, parachute pants. How well does that go over today? Not too well, right? So if we've moved on from parachute pants, maybe we need to move off from the system logging as well. But what? No, Chris, we've been doing it for years. We got to tweak, we got to tune. You're talking about other people, not me. No, this is impacting all of us. The sad part is the data to show that this doesn't work is right in our face. But I think sometimes we don't know what else to try, or we've got that cognitive bias going that we just keep doing the same thing anyway. So we're doing the same thing over and over, expecting different results. What's that the definition of? And if you look at the data that's out there, it screams this does not work. When you look at the industry average between when an attacker successfully gets a beachhead on a network to when it actually gets detected, it's 6 months or more. We keep talking about this over and over again. And I will continue to beat on this until this number gets smaller, because, oh my God, this is the biggest problem we have in cybersecurity today. That 6 month plus gap between getting a beachhead and actually getting detected, that's horrible. Further, when you look at when it gets detected 6 months later, so think about that. It takes 6 months to detect it. Why does it take an organization so long to detect it? Well, the answer is they usually don't. It's usually an outside third party that goes through and detects it. Citrix is a great example. So Citrix, they're an IT-based company. They should do well with security, and I assume they do for the most part, but they got compromised. They had customer data leaking out, and it had been going on for a while. How did they detect it? Well, it wasn't log review. It wasn't anything they were doing, because if it was, they would have caught them in like the first week. What finally caught it was the FBI going to them saying, hey, so we found this data out on the internet, and it looks like it came from you. So again, it's that 6 month delay to detection. And when detection takes place, majority of the time, it's an outside third party. So system log to try and find threats on our network. How well does that work? Yeah, not very, right? Verizon's last breach report, if you go in and you dig into that, log review caught things about 2% of the time, 2.5%. So roughly, if your network gets compromised 50 times, you'll detect one of them. Oh my God, that's horrible. That is not acceptable. We need something better than that. Further, when you look at things like take it off of desktops and servers, when you start looking at common devices like point of sale devices, anybody processing credit cards probably has a point of sale device, especially if they've got a brick and mortar location. When you look at the Verizon breach report around those systems, when point of sale systems got compromised, exactly 0 were detected by system log review, and exactly 0 were detected by the organization themselves. It was always an outside third party. Ouch. Now, wait a minute. PCI requires system log review. It's part of section 12 or 13 or somewhere in that range there. But they require you got to be going through your system logs. So it's there. It's a requirement. People are doing it. And yet, like I said, log review will catch 1 out of 50. And if it's point of sale device, yeah, you're probably not going to catch anything at all. Ouch. So we need something different. So one of the things we're going to focus on in this class is start on the network. And this is the reason why. It isn't just, hey, let's try something different for absolutely no reason. This is when you stop and really look at what we're doing today, and you look at all the statistical data that's out there on how well does it do, it dies horribly. Again, 1 out of 50. No, that's not acceptable. We got to be able to go in and we got to be able to do better. Now, we have tried to kind of mix it up a little bit, right? So we're doing system log review. We're also using threat intel to go after things, right? What's threat intel? Well, threat intel, and I want to get this stuck in your head. If the technology you're trying to work with to lock your network down, has a very close resemblance to 1990 antivirus technology, don't use it. It's too old. You need something better. And Intel feeds are basically 1990 antivirus as well. Because what are you doing? You're saying somebody, we'll talk about who that somebody might be in a minute. Somebody detected malicious activity with a remote IP address, so hey, I should go in and block that too. Well, that's like the epitome of 1990 antivirus signatures, right? That doesn't work. In a previous life, I worked for a domain registrar. So I worked for someone that you could go to buy domains from. Mining their databases to look at what are the bad guys doing, one of the things you pick up on very quickly is that for the folks that are even half clueful, I'm not talking nation state, I'm talking just half clueful. For the folks that are half clueful, they're changing the domains, they're changing the IP addresses they're using constantly. The IPs probably change on a daily basis. The domains themselves are changing at least every week, at least at a maximum. So if I get a threat intel feed that tells me here's an IP address I need to worry about, the amount of time it took to do that research, figure out that's an IP to worry about, and get me that information, it's already out of date. It probably does me no good. And I'm taking information from a lot of times unverified sources. Even if I'm paying an organization to give me this threat intel list, that doesn't necessarily tell me, did the person who ran this down actually have a clue about what they're doing? Meaning at the end of the day, it kind of comes down to skill set. And I love picking on Bing for this one because Bing is constantly getting banned. Bing is a search engine, just like Google. Bing is still out there. Some people still use it. And as a search engine, it has web crawlers. So it has web crawlers that run around the internet looking for content that it can then go through and it can index. And that gets it banned constantly. So if you look at what's on the slide, just block it. 1,465 website hits in one day, not sure why. I can tell you why. There's probably 1,465 pages on that website, and that's why Bing went through and hit it that many times. You get the idea. A lot of folks will look at things when they don't recognize what's going on rather than doing the research to really run it to ground. They just assume, well, I don't understand it, so it must be evil, so just go ahead and block it. That's the easiest way to deal. So now you're blocking stuff that just doesn't matter. And even then, a lot of this stuff tends to be in dynamic IP space. So, when you look at this threat intel feed, two things. One is the date you get out of it is the date it was extracted from the database, not the date it actually was created as an entry. And that's important because an IP address that was added to this database yesterday has a lot more value to me than an IP address that was added to this database 6 months ago. Because again, if attackers are constantly changing up their sources to show me something from 6 months ago, that is completely useless. Further, most of these are shared IPs. They're either coming out of a public cloud instance. So this might be like an EC2 instance IP address. Okay, those are hard to change, right? Shut my server off, turn it back on again, and I've got a new IP address. And now that IP is somebody else's problem. And if you go through and block it at that point there, you might actually be blocking a legitimate service. Or there might be a single server that's hosting like 50 different websites, and one of them was evil, the other 49 weren't. Well, now you've shut off access to all 50. You're throwing out the baby with the bathwater type. Now, we've got network-based intrusion detection, and I see folks coming back to this a lot in the Discord channel, talking about on the network threat hunting channel. We've been kind of talking about like how to go about catching C2 detection. And a lot of folks have been asking about, well, can I do this with Snort? Can I do it with Suricata? Can I do it with one of these signature-based things? And my experience has been, no, not unless you've gone in and written the signatures yourself. And even then, what you will catch is what you've seen in the past, not necessarily anything new. So later today, we're going to go through and we're going to do a bunch of labs. And what you'll find is that there's some long connections in there that need to be looked at. There's some beaconing traffic that's taking place that needs to be looked at. There's some actual C2 communications that's taking place. If you take that PCAP and you run it through Snort or you run it through Suricata, I ran this through Suricata with the emerging threats data set. This is what it flagged. So it identified, hey, somebody plugged in a USB device and now that computer's going to Microsoft to see if it can't find the right driver for it. Okay, that's kind of interesting, but that's not the C2 channel I wanted to actually find in there. It's also flagging, oh, hey, there was a DNS query to the .cc domain. Someone else might have registered, Microsoft.cc, and they're using it for phishing. Therefore, that might be something you need to pay attention to. Well, they're not saying this was actual phishing. This is simply getting triggered just because somebody had .cc in their domain. So you're going to get a ton of false positives. And again, this has nothing to do with the two C2 channels that are actually in this data set. So can you use Snort or Suricata or some network-based intrusion detection for this? Of course you can, but you got to write your own signatures, and you've got to realize that that will catch what you've seen in the past. Now, it is good for that. If I go through, when I do a real hunt, and someone came at me and they created a C2 channel with DNSCat2, yeah, go in, write a signature for that. So now if it happens again, bang, I immediately get an alert. But don't rely on that. Don't say, oh, I don't need to threat hunt anymore because I wrote a signature for my IDS. No. Because all the attackers have to do is go in and change up what they're doing just a little bit, and they're going to start flying back under your radar again. So this is in addition to threat hunting, meaning that threat hunting is how I go about finding the new and interesting stuff that attackers might try and do, and then I feed signatures for that into my NIDS. And now if that happens again, I see it. And I see it a lot easier than having to go through and do a full threat hunt. But I still need to keep doing the hunts to be able to find the new and interesting stuff. So what is threat hunting? What should it be? This should be a validation of the integrity of every system on your network. Meaning if I look at everything plugged into the wire, a real threat hunt should be a validation of every single one of those systems to identify, is it in a compromised state, yes or no? And it needs to be everything, not just servers, not just desktops, but all your network gear, any industrial Internet of Things devices you have out there. I was reading an article recently that someone went through and whacked, I think it was like D-Link routers or something like that. And they've been using them for years to be able to go through and pull down anime videos. But they just went out and whacked like 10,000 different systems out on the internet. The problem was no one is threat hunting those, because if they did, they'd see the C2 channel. So network gear, industrial Internet of Things, we got to be able to go through and cover everything. The output of this is what's referred to as a compromise assessment. So compromise assessment, think of it as like a certificate that says, hey, I've looked at every single internal system, regardless of platform type, and I feel fairly confident that none of it has command and control channels running to it, which is a clear indication that none of it should be in a compromised state. That's what a compromise assessment is. So again, a threat hunt, I talked about that 6-month gap. We've got our protection tools to keep people out. We've got decent forensic methodologies to be able to run stuff down. That 6-month gap is really an expression of how do we figure out when our protections have failed and we need to go into incident handling mode. That's that 6-month gap. We want to get this as small as possible. Now, folks always get caught up in real time. I hear this a lot from people. Oh, can it do it in real time? Can it do it in real time? Don't worry about real time. 6 months. So if you start threat hunting every other month, you're still in better shape than you are today. It's not real time. There might be a 2-month delay. I agree with that wholeheartedly. But if you're consistently catching things every 2 months as opposed to 6 months or more, and then by an outside third party, you're still magnitudes better than the shape that you're in today. So the process of threat hunting, we want to go through, we want to do an integrity check on everything. We'll talk more about what that means in just a little bit. When you think about what's a threat hunter's job? A threat hunter has one job, and that is to validate the integrity of every internal system. So validating the integrity really comes down to one of two possible dispositions. I need to be able to go through every IP on my internal network, and I need to be able to make one of two different claims. Claim one, I'm pretty certain the system is in pristine shape. It's still safe, nobody's compromised it. Possibility number two, I think this system has been compromised. We need to go into incident handling mode, potentially forensics, possibly get PR involved or legal or whoever. Something bad has happened and we need to run that to ground. There is a third possibility, which is I'm not sure. But when we're not sure, that mandates that we do additional things to be able to go back and come up with one of those first two options. In other words, if I look at something and say, man, it looks suspicious, but I'm not really sure if that's a compromised system or not, I can't stop there. I need to next plan out, okay, what can I do to try and figure out what's wrong? Maybe it's pivot into the host logs. Now that I know, hey, that system's acting weird, maybe the next step is to go into those system logs. Notice what I'm doing differently versus what we talked about earlier. Before, we were using patterns. We were using things like how many failed logins took place to kind of figure out what to go in and look at. So we're pattern matching. We're using that kind of 1990s technology. What we're doing here is we're saying, okay, we're watching the behavior of our systems. We're seeing indications that this one might be compromised. I don't know for sure. It might be. I see something that could be a command and control channel. I need to find more. Now I pivot into my system log. Well, that's kind of cool because now I can go into my system logs and say, show me that source during this time frame, and it's directly applicable to the suspicious behavior that we've observed. So our system logs now become a lot more helpful. We're not generating alerts that we learn to ignore. We're focusing in directly on what might actually be a suspicious issue on our network. Makes life a whole lot easier. So we used to start with the system logs, and we miss stuff. Again, 6 months or more. So what we're recommending is start on the network. Use that to identify which systems are actually suspicious. And then once you've whittled that down, now go into the system logs. And don't go into the system logs just looking for alerts. Go in and leverage that context to figure out what's going on. Hey, if I'm looking at an internal desktop that's beaconing out to Guangzhou, China every 30 seconds and I don't know why, maybe the next thing I need to figure out is what application on that system is doing that. If it's some software that I then run down and figure out, oh yeah, that is a software package we bought, and yeah, they're located their servers in Guangzhou, China. Okay, great. I know that's okay. I can whitelist that going forward. I'll talk more about what whitelisting means just in a little while. But if I look at that and say, oh no, that was some binary that makes no sense, or it's something running out of the Windows temp directory, yeah, no, that's a problem. I need to run that down further. So again, by going network first, then host, our logs are actually reinforcing this process that we're on, and all of our data is actually viable. We're not saying, oh my God, I'm getting millions of log entries a day, so let me try to whittle out just a couple of things that I think are worth looking at. No, we're saying this system, this time frame, these applications, this is what I need to drill down on. That makes life so much easier. And I'll give you an example. So warning, this is a little bit of a salesy thing, but I'm going to come back and kind of show you open source options a little bit later. But just to kind of show you, we're eating our own dog food. This is AI Hunter. So this is our commercial threat hunting tool. So it goes through the network. If you look at this bottom graph here, this is showing me how many times did this source IP connect to that destination IP every hour over a 24-hour period of time. And you can see every hour it's connecting pretty much the same number of times each time. That could be a beacon. That could be an internal host calling home to try and get its marching orders. So I look at that and I say, that looks a little bit suspicious to me. Now there's a lot of things I could run down. I could start looking at the protocol, reputation of the external system. But one of the things that would kind of help me figure out very quickly, do I care, is if I could see what application was running on that system that is generating all of this traffic. So we've created a new project called Beaker. And I'll come back and talk more about this later. Beaker is an open source project. It's basically an ELK stack that goes through and collects sysmon data to be able to show you, hey, if you see this on the network, give you a quick, easy way to kind of pivot into it. And within AI Hunter, we just created a beacon icon to go talk to Beaker. But when you click on that icon, it immediately jumps in and filters the traffic for you to say, okay, that source IP, when it was talking to that destination IP, this was the application that was running, and this is the user that was running. Okay, so let me back up a sec. So here, I'm looking at this and saying, yeah, that's suspicious. I know it's something worth investigating. I don't know for certain if it's evil or not. I'm leaning towards evil, but I don't know for sure. By immediately just pivoting into what application created that data, wow, yeah, okay. If Anthony Caldwell is working in accounting or working in HR, accounting, HR, sales, basically everybody outside of the security group has no reason to run PowerShell. So if I'm seeing that, yeah, this is something I need to be concerned about. Notice how quickly we ran this to ground. Just by starting on the network, we're only looking at systems with suspicious behavior. So we've probably weeded out hundreds, if not thousands or tens of thousands of systems very quickly. And then once we did that, once we get into the suspect category, by pivoting into and leveraging those host logs to see what application created this connection, bang, we're able to run this down to ground very quickly. A real hunt, how long would it take us to run this down? As long as I could find that network data pretty quickly, maybe 2 minutes to go from, whoa, this is suspicious, to, whoa, we're going to have a really bad day, possibly a really bad week. So that makes life a whole lot easier. It's not in Beaker yet, but one of the things we're going to add in on the next version is the ability to go in and do an audit on this. So imagine I was on this screen and I said, okay, show me the host data. And when I went to this screen, nothing's there. Okay, there's 3 possibilities why nothing would be here. Number 1, Sysmon's not running on that system. Okay, that's a IT type problem. We need to get Sysmon running on it to be able to collect up that data. Possibility number 2, Sysmon was running, but it crashed or somebody killed it. Okay, be kind of nice to know about that. Possibility number 3, why there might not be data here, maybe somebody hid the process. It's not that hard if you know what you're doing to hide running processes from Windows or even, well, Linux is harder. It's not impossible though. But on Windows, it's not that hard to hide your running processes so that you don't see them. So how do I tell the difference between the 3? One of the things we're adding in is an audit function. So if I get to this screen and there's nothing here, I can click a quick audit button. And that'll come back with another screen that shows me, hey, this internal IP address, during this specified time frame, we saw Chrome connecting to these websites. We saw Windows Update connecting to those websites. We saw, all these other traffic patterns taking place. Great. So if I'm seeing those traffic patterns, but not this one, someone's hidden a process. Ouch. That's something I need to react to fairly quickly, right? So again, start on the network, go to host. That makes this thing go very, very quickly. So where do we start? I've talked about this before. 12 hours, 24 is ideal. I've had people ask me, what's the shortest time frame I can get away with? What's the smallest amount of data blocks I should be working with here? And ideal world, it's 24 hours. Can you do less than that? Sure you can. Somebody, kind of stuck on, I want to do 2-hour captures and hunt on that. Go for it. Because number 1, it's better than doing nothing, right? I'm not going to say, no, don't bother. Yeah, go for it. But know that if somebody has a really long beacon interval, if this thing's calling home once per hour, you're not going to see that in a 2-hour capture. It'll be hard to see, but possible to detect in a 24-hour capture. But you're not going to catch that in a 2-hour capture. If you're going after long connections, where people have gone in and have created a connection out to some host out on the internet, and they're using that for their C2 channel, if you only capture 2 hours worth of data, you're going to find a lot of them that are in there. Many, many false positives. And then you're going to have to sort through all of them because it's not that uncommon to have something kick off for a couple hours within an internal environment. So what do you do? Well, again, if I have a longer time frame, I'm going to have fewer false positives I need to sift through because I can set a longer time frame to look at. The one I recommend is usually 5.5 hours or more, about 20,000 seconds. Again, how long should you keep? The more data you can keep, the easier this becomes. It takes longer to process the data, but the easier this becomes. You can do PCAP captures. A lot of folks are comfortable with that. They've worked with it for years. I have to be honest, I'm a real Zeek fan. I really love using Zeek. I love using Zeek because Zeek takes up about 1/20th the storage of PCAPs, but it gives me all the data I really need to be able to run things to ground as part of a threat hunt. It'll go through and show me who talked to who and when, how many packets went back and forth, how much data went back and forth between the two, what was the timing of those connections. It really gives me everything it needs, and it does it in a small amount of storage. Now, if you're thinking about, well, yeah, but Chris, I'm not really worried about storage. Storage is cheap. I can throw more storage at this if I need to, not a problem. It's not just about storage. It's also about processing it. When we get into doing the labs, one of the labs, specifically, we're looking for C2 over DNS. There's 2 labs I give you. One does it using Zeek, and the other one does it using PCAPs. For many of the folks, they'll be able to do the first one, but not the second one. Or they might be able to do the second one, but they notice it takes like 100 times longer than the first one. Why is that? Well, because PCAP's given us more data to parse through. It's not just about storing that data, it's about processing it and going to look for the interesting stuff. So because Zeek is smaller and more agile, it becomes a whole lot easier to go through and do our hunts on it. So like I said, I tend to be a big Zeek fanboy, but if you don't want to use Zeek, you want to use PCAPs, again, it's better than not doing anything at all. Okay, so we're grabbing this data. What do we look for? And is there an order that matters on what to look for it in? Yeah, the first thing we want to go looking for, persistency of connection, because this is going to allow us to eliminate a lot of systems very quickly. So imagine we're threat hunting on a network that has 10,000 systems on it. I have 10,000 endpoints on my internal network. If I have to look at every internal system and scrutinize every connection that's made to every IP address on the internet, oh my God, just a day's worth of data is going to take me months, if not years, to go through and do, right? So I need to be able to set some boundaries around what's worth, what stuff can I immediately dismiss and say this is not worth any time at all. And persistency of connection is really it. If I have an internal IP address that is not communicating with somebody on the internet on a fairly regular basis, yeah, get that out of the way. And that's going to describe most of your internal systems. So out of those 10,000 systems, I might be able to very quickly eliminate 9,000 of them, just throwing out round numbers, but a big portion of them just based on the fact that I'm not seeing any persistency of connection that looks like it's been programmed in. Once I do that, the next thing I like to look at is abnormal protocol behavior. This could be somebody breaking the protocol rules. This could be somebody bending the protocol rules. And I'll dig more into what do I mean about that as we go through. The next step really depends upon your environment. For the environment where we don't do any system logging internally, we don't keep track of systems, folks can plug stuff in, get an IP address, start talking on the internet. I don't know who's using what IP address at any given time without going through my DHCP logs. Start with the external host. It's probably going to be a whole lot easier to run down its reputation. If, however, I'm collecting system logs, I'm keeping track of who's doing what internally, I've got some good data on my internal systems, you might actually want to do the internal system first, then go look at the external host after that. The reason this order matters is because you're trying to eliminate the largest number of possibilities first. So I may go through and look at persistency of connection, and like I said, out of my 10,000 hosts, 9,000 of them go away, and now I've only got 1,000 hosts to worry about. And when I go through and check for protocol abnormalities, that might get rid of 750 of them. And then I go in and I look at reputation on the external system, and that might get rid of 225 of them. So now when I get into running down the internal system and whether it's actually suspicious or not, I might only have 25 systems to work with out of that original 2,000. So again, the order kind of reflects how do we get rid of potential false positives as quickly as possible. This is the order we found really kind of works the best. And come up with a threat score system. There's no standard for this. I kind of hope we move towards one as a community as we go through, but that's for something outside of this webcast to kind of talk about. What you want to avoid is freezing up and not being able to make a decision, or ending up in this kind of loop where you just never finish. Meaning that it's easy to kind of get in this mode of, is this system worthy of an incident handling process or not, yes or no? It's real easy to say, well, we could look at this. Oh, wait, let's look at this. Oh, wait, hey, look at this. Oh, wait, hey, look at this. Oh, wait, hey, look at this. And then it never goes away as an action item. It's this constant cycle. So this is where the scoring system comes in. So imagine I've got a point scale of 0 to 100. 0 is I know it's safe. 100 is I'm pretty certain it's compromised and we need to go into incident handling mode. Now I just come up with modifiers for the different types of things I look at. So persistency of connection, that should be a major modifier. If I'm seeing an internal system that connects to an IP address out on the internet that I don't recognize once per second, that should be 75 out of 100 points, maybe 80, somewhere in that range there. Now I'll run down, the reputation for that external host. That's a minor modifier. That might add or subtract 10 points. hey, this is going out to Russia. We don't have a field office or anything in Russia. Okay, maybe that adds in 10, 15 points. So now we're getting pretty close to that 100. Maybe it's going to Microsoft's control network. It's in that ASN that all of their patching servers are located in. Okay, maybe that subtracts 5 points from our threat score so far. So now we're starting to move back towards, yeah, actually, it might actually be in pretty safe shape. So come up with some modifiers to work with and come up with some boundaries, meaning that we say 0, I know for certain is safe. You're not going to hit that all the time. So maybe you say, okay, for anything that's a score of 0 to 20 or 0 to 40, I'm going to assume it's safe and put it aside and stop worrying about it. Anything that scores 90 or higher, yeah, that's something that's worthy of doing additional investigation work on. So it might not be a perfect 100 score, but it's close enough. We need to go in and hit it from there. And, find a scoring system that kind of works best for you. So like I said, you'll have major modifiers, you'll have minor modifiers kind of based upon what it does for you. Good example, threat intel. Threat intel for me is a minor modifier. If my internal system talked to somebody on the internet that was on somebody's ban list, yeah, that's 5 points, maybe 10. The exception is how much data has been transferred. If it's like a megabyte or less, that's a pretty common indicator of my system tried to connect to that host maybe once or a couple of times. Typically, it'll try 3 times. And that socket wasn't even open on the remote system, or that system was offline at the moment, or whatever it was trying to get to was unreachable. Really what that comes down to. It's not uncommon to see like a megabyte or less worth of data go back and forth as part of that. So, again, if I'm seeing a megabyte or less, yeah, 5, 10 points maximum for that makes a whole lot of sense. What if I see 100 megs? Well, wait a minute. I know I don't trust threat intel lists, but if this thing's on a threat intel list and my system is moved, 20 megabits, 50 megabits or more, yeah, I really need to run that down and pay attention to it. So your threat scoring system shouldn't necessarily always be kind of a flat plus or minus. It isn't necessarily always, oh, we add 10 for this, subtract 5 for that. Sometimes you might need some little modifiers in there. If it's a megabyte of data transfer, yeah, that's 10 bytes on a threat intel list, and that's it. If it's 20 megabytes or more, yeah, we start adding points exponentially at that point. Again, more data gets transferred, more likely I need to go in and kind of pay attention to that. So we're talking about targeting C2. So if you think about malware gets on an internal system, let's say we've got an attacker that has written custom malware. They've run it through one of the many websites that are out there today that'll check it to see, do I recognize this as malware, yes or no? We all leverage those sites, right? We see a suspicious file. We'll run it through one of these websites to see, has anybody tagged this as being potentially malicious? And we use this as part of our investigation processes. Well, the bad folks use that too. So if I go in and I write custom malware, I'm going to run it through those sites to make sure nobody's detecting it. Because now I know if I can drop it on your endpoint, it doesn't matter what endpoint solution you're using. You're probably going to miss this malware, and I'm going to be able to do bad stuff on your network. We can try and target the malware, but since it's getting customized all the time, that makes it tough. When you start talking about C2, though, there's some behavioral characteristics there that just can't be avoided. Like the internal system that's been compromised needs to call out to a server. It needs to do it on a fairly regular basis. If we can find that pattern in with all of our regular data patterns, we're going to be able to tag this and kind of run it to ground, which is cool. So we found hunting C2 traffic is a very successful method to go in and identify, has an internal system been compromised, yes or no? Now, it's not perfect. There are instances where hunting for C2 will miss it, and NotPetya is probably a great example of that. If you're not familiar with NotPetya, NotPetya was, let's call a spade. Russia went after the Ukraine again, and they decided they wanted to destroy as many computers within the Ukraine that they possibly could. So there was one Ukrainian system that everybody in the Ukraine that did business needed to connect to because it was used for processing taxes. And they compromised that system. And now when people connected to it, they downloaded some software off it that, again, didn't flag any antivirus software. But what that did was it tried to spread on the local network as quickly as it could, compromise as many endpoints as it possibly could, and then went through and nuked the system that it was on. So there was no C2 component to that. It was a true full-blown worm. It was a worm that would get on a system, worm its way onto other boxes, and then blow itself up when it's done. So it's the cybersecurity equivalent of like a nuke. There's no tactical strike here. There's no trying to go undetected or anything of that. No, no, no. The one job it had was doing damage. When a nuke goes off, you know it. There's no way to hide that. And this did the same type of thing. So if you are let's say, a military organization or a government organization, destructive worms like this might be something you might actually need to be concerned about, in which case you may want to come up with some techniques to kind of work around that. For most of us, though, if an attacker gets in, there's something they need from you to have that be a payoff. It might be use of your computer resources. It might be stealing local information. There's some transaction that needs to take place to make it beneficial to them. And that kind of requires them to be able to control that host and stay in communication with that host, or the need for a C2 channel. So hunting C2, it's going to be useful 99% of the time. That 1% where it's not useful, do you need to worry about that? You need to make that risk call for yourself. And if you decide, yeah, I'm in that risk category, you need to come up with some additional techniques to be able to go after that as well. So where do we go from here? Well, like I said, as an industry, we really need to start making this happen. The whole concept of network threat hunting, part of the reason why we're doing these for free, not enough people are doing this. Not enough people have really adopted this as part of their standard practices. So this is something we really need to go in and run to ground. All right. It is almost 5 minutes of the hour. So I'm going to call a break at this point here, because we're going to start changing gears a little bit from here forward. We're going to take a break until 5 minutes after the top of the hour. So bio break, get yourself something to drink, get yourself something to eat, go for it. I won't move content until we get till 5 minutes after.
And what Chris doesn't know is that it is not a full break. This is the part where I step in for him and I answer questions and he goes on a bio break. So if you have any questions, type them in and I'll be happy to hijack this webcast. So go take a break, Chris. We'll see you in 10.
Awesome, dude. Thank you so much.
All right. So we got some questions that people were talking about. Some issues are having some problems getting the VMs up and running, and that's perfectly normal. We will see that from time to time. And remember, these labs that Chris has created are designed so that they can continue, and you can continue doing them after the class. It's not like some magic lab that you only get access to for this particular week as well. One of the questions that came up is what is going to be different. They wanted a little bit more data as far as what's going to be different on the next webcast. As I mentioned, I want to do a pivot a little bit to endpoint analysis. And I don't want to get too crazy into forensics, but what we're going to be doing is saying if you have a network artifact, if you have beaconing on a system, what are some things that you can do to do analysis on an endpoint to be able to identify whether or not that endpoint is actually compromised? That's going to be number one. So if you see a network connection, something looks fishy on a Windows system, how would you be able to look at the network connections with like netstat minus NAOB on a Windows system, or LSOF space minus lowercase I and then P for basically showing you the process information. And then in the open internet connections with list open files. So we'll be talking about that initial kind of live forensics on endpoints. We're also, because it's threat hunting and we don't want to spend too much time with live forensics, we're also going to be talking a little bit about how to do long tail analysis. A huge part of network threat hunting, as Chris has already talked about, is looking for those anomalies. Now here we're talking specifically about network-based anomalies. One of my huge pet peeves is many people in the threat hunting world seem to think it's all about indicators of compromise, that we're going to be able to identify signature-based things, like we'll be able to do hashes or a string in a Yara file, and we'll search that string, or a process mutex, and we'll be able to find all the malware by doing these types of lookups in an environment. But that is traditionally a blacklist approach. So if you look at what we're talking about here today on the network, we're trying to find anomalies. We're trying to find weird things. And then on the endpoint, we're going to be talking about how you can do very similar things by doing frequency analysis and long tail analysis with tools like Consa, SCCM, maybe Tanium, if you have it in your environment as well. Also, I'm going to talk a little bit about OS Query, and then Waza, which is basically a really cool iteration of OSSec. So some really cool stuff coming up. Pretty stupid question, but should I run the VM as headless? It doesn't really matter. If you can log into it with just a terminal, you're good to go. There's not going to be any like full GUIs that we'll be using on that one as well. So that'll be coming up as well. What is this course, pray tell? And it just moved as I tried to click on it. How to sell security to C-levels. So Chris is going to be talking about when you're discussing computer security to the C-suite, how do you actually effectively communicate to them? A lot of classes, whenever you talk about communicating effectively with upper management, they'll be like, okay, so the first thing is you've got to wear a suit and you got to be using phrases like return on investment, and that's all crap. Chris and I have talked to C-level suites and owners of multi-billion-dollar companies, and we didn't have to become something we're not in order to do it. So we're going to be talking about how to effectively communicate with upper management. No Velociraptor up? Okay, so Velociraptor, I can't remember the gentleman that created it, but he was behind the Recall project when he was at Google. And Velociraptor is really, really promising, but I just don't feel like it's quite there yet. And I know that I might hurt some people's feelings, but Velociraptor is really cool. But I just don't think it's quite at that point. We also have GR, Google Rapid Response. We can talk about that as well. So there's a ton of different things. Izzard the Wizard said, I'm totally new to blue teaming. Is this webinar beyond my scope? You know what? At some point, you're going to have to jump into the cold water. So jump in. One of the things that's really cool about our webcasts is we are never going to tell you you suck, you're a noob, try harder. As awesome as that is for offensive computing and what they're doing there, we firmly believe that when people are getting started in computer security, especially as defenders, they should feel comfortable to ask questions. And that's why we have a number of people here helping out as well. How did you see? Oh, yes, go for it.
Hey, I know you have questions, but I have one here for you. Will you be discussing how Rita and ADHD and how they fit into threat hunting strategy?
Okay, fantastic. So if you're looking at ADHD, the whole purpose of the free training that we've done, and we can maybe get someone to drop a link in here as well. I ain't no noob. Okay, fine. I didn't mean that. But ADHD is designed to think of threat and tell about what's happening at your organization right now. So how can you detect people that are port scanning, mess with their ability to port scan? How can you actually detect if you think that there's a workstation that is compromised to do cyber attribution on who is actually on that workstation? So there's a lot of active defense and cyber deception whenever you're doing threat hunting, because you're setting traps for the adversary to actually fall on. It actually ties to a hunting analogy. If you're hunting, you're going to be going down and watching a game trail. You're going to be watching where the deer or the elk actually move. You're just not going to be walking around. So we want to talk about setting proper traps in those locations. Sorry, I have yet to come up with a better analogy that doesn't involve killing fluffy little animals. Now, when you're talking about RITA, Real Intelligence Threat Analytics, which is what Chris is going to be talking about here quite a bit, is you're actually building RITA in this session for the rest of it from the ground up. So you're not just going to be running RITA as a magical black box tool. Chris is actually going to be walking you through exactly what RITA is doing to be able to do beaconing analysis, to be able to do blacklist checks, to be able to do long connection analysis as well. Any other questions, Jason?
Yeah, I had another one. Is it possible to do hunting in a network with more than 100,000 endpoints? If yes, how to manage logs?
Yes. Absolutely. All right. So anytime you're trying to approach any type of threat hunting in a network that's 100,000 nodes, here's a dirty little secret. There are no networks that are over 100,000 nodes. Now, some people are going to disagree with me. Give me a second to finish my thought. I've worked with some of the largest networks on the face of the planet. And when you get into any of those networks, you're not really dealing with 100,000 nodes on a flat network. What you're actually dealing with is 100,000 nodes where there's a bunch of nodes in DC, there's a bunch of nodes in LA, there's a bunch of nodes in Washington, or in New York, there's a bunch of nodes that are there for HR, there's a bunch of nodes for development. If you take an organization that's that large, it actually breaks down into a bunch of smaller segments, either by geographic location or by job function. So if you're going to approach threat hunting, you want to break your organization up. And a lot of times you can actually go to group policy and see what groups are defined for those machines and actually start doing your threat hunting on those specific groups or geographic locations. So don't think of it as 100,000 nodes. Think of it as a whole bunch of smaller organizations that are working together, and break them up appropriately. What other questions do we have?
I just want to let everyone know I'm posting a link to your 4-hour free training class that we did. The recordings are available everyone can download the VM and practice with ADHD. And I'm posting it in the GoToWebinar chat, and I'm posting it in Discord. And then, John, you can go back to going one of your own questions.
JTom78 said, what about imposter syndrome? Look, as long as you have imposter syndrome, you're in the right place. I knew I was starting to become technically irrelevant when I didn't have imposter syndrome. It doesn't really mean that I don't have imposter syndrome. It's just I've done this more than almost any human being walking the planet. Teaching for SANS, I've taught, I don't know, it was probably over 150 times, maybe more. 504, and that's 6 days of training, 8 to 9 hours a day. So I really don't get freaked out getting up and speaking to people about computer security just because I've done it a lot. But if we go back to the beginning, as far as when I first got started, oh dear God, I shouldn't have been teaching anybody anything about computer security. Imposter syndrome is healthy. If you're constantly going through and identifying areas that you're weak and trying to address those areas, you're in the right place. I'll give you a quick little tip, just something that I don't tell many people except on webcasts and presentations in large rooms. Ed SCOTUS. So here's a little story about Ed. Ed SCOTUS is without question one of the smartest people I have ever met. He is one of the godfathers of computer security. And hell, he's probably one of the inventors of what modern pen testing is today. He's that important. But years ago, whenever he was working with a little consulting firm called Intel Guardians, not InGuardians at that time, but Intel Guardians. He was sitting around in a meeting with a bunch of the main people at Intel Guardians, the founders, and he noticed that all of their computers were Macs or Linux computer systems. And he went around the room and asked them, do any of you use Windows? And everybody laughed, and they're like, Windows? We break into Windows systems. And he realized at that point that that was a weakness for him, and it was a weakness for his company. And he set out for 2 years. Bill remembers this because Bill was still teaching at SANS whenever this was happening. Ed was almost insufferable at the lunch table. He was constantly showing command line stuff on the Windows, and he's like, oh, check out what I can do from the command line. And Bill and Hal were like, well, I can do it faster and easier in Bash. And Ed's like, it's not the point. 2 years. That dude sunk into the Windows command line and learned everything he could about the Windows command line. And then he started blogging about Windows Command Line Kung Fu. And then he started the Command Line Kung Fu blog with Hal, Paula Zadorian, and then Tim Bedeen came in. And he kind of revolutionized the way that people looked at Windows. He was there at the beginning. And all of that started from him realizing he was not strong in an area, stepping up and trying to address that area that he was not strong in. And the industry is eternally grateful for it. So
yeah, absolutely. It's great that he kind of recognized that that's a weakness because we all focus on the platforms that are easy to secure when the one that's hard to secure is the most popular. No offense to anybody. Yeah. Hey, absolutely. John, if I could, quick plug. If you were thinking about doing presentations, we are going to have an upcoming talk on how to give technical talks.
Yes.
So if you haven't done this before, if you've done it once or twice, but you're still not sure how to do it, if you're uncomfortable with the idea, we will absolutely be doing that at Wild West Hacking Fest. And I believe we also have a course coming up in June. Keep an eye out for the mailing list. We'll definitely announce it in advance.
So I got to thinking about that, Bill. I think Chris is just about back. Yep, so you remember years ago, okay, cool. Guys, do you remember years ago we used to do murder boards at SANS where we had people present and we were as hard on them as we possibly could? I want to know, would anybody be interested in, like I'm talking to the people here that are attending, would anybody be interested in doing, like going through Bill's talk, getting your feet underneath you, and then going through a full SANS instructor murder board? To basically go through and see the worst possible student that you could possibly encounter and how you deal with that, how you sidestep those issues. If anybody's interested, I'd watch. Look at that. Somebody's like, I'd watch that. That sounds like fun.
This going to be like a T-shirt or a sweatshirt or something in it for the people that go through that and make it and come out the other side?
Oh, I would say yeah, absolutely. For anybody that goes through it, we do something like a deck of cards or things like that.
That goes beyond a deck of cards. Shelby, start thinking about this.
Sure. We'll send you a car. All right, whatever. All right, so Chris, I'm handing you your class back, sir.
Awesome, man. Thank you.